Well, thank you everyone for coming. My name is Srikanth Sugavanam, and I'm working with SKI as an assistant professor. So my area of work is in the area of fiber lasers and photonics, but I teach subjects here related to measurement and instrumentation related aspects apart from photonics. So today we'll be looking into the Arduino and the Raspberry Pi platforms. So I understand that there have already been some lectures on this topic. I believe last week it was Dr. Siddharth, who was talking to you about IoTs, and he also entered into a lot of detail about the different kinds of platforms that you can work with. So I believe he talked about Node MCUs and Raspberry Pis, and he showed where you can apply it. So I thought that I'll take a slightly different approach today, and I would like to walk you through how you can, if you get your hands on an Arduino, how you can start working with it right away, and what are the different kinds of programs that you can immediately start using, which will form the basic building blocks of your eventual DP projects. That's brilliant. Okay, so I see that several of you have not worked with Arduinos and Raspberry Pis, and that's perfect because the DP gives you an opportunity to actually work with them hands-on, because you can read a lot about the Raspberry Pis and the Arduinos, and there is a lot of information out there. But is somebody talking? Does somebody have a question? Okay, so there is a lot of reading material and a lot of YouTube videos out there where you can learn about Arduinos and Raspberry Pis. But the best way to learn to work with them is actually by working with them, and hopefully the DP will give you an opportunity to do that. Okay, so I have 40 minutes, and in that 40 minutes, I have to cover both Raspberry Pis and Arduino. So let's see how far we go. Let's start with the Arduinos because it's very likely that you will start using that. So the Arduino is a simpler platform in comparison to the Raspberry Pi because, as you would have already heard from Siddharth, for instance, the Arduino is using a microcontroller, and it is a microcontroller platform programming the microcontroller. On the other hand, the Raspberry Pi is a microcomputer, which means that you can actually use it as a computer. You can actually use it to surf the net, play games, watch videos, and do programming and all that. So it's actually a fully functional computer in itself. So there are these two differences. There are pluses and minuses to both of them. So we can discuss that at a later point in time. Right now, we start working with the devices. Okay, so first of all, let me just show you what the Raspberry Pi looks like in case you haven't seen it already. So let me see if I can pin myself to the layout. How do I pin myself? Switch, right. Right. So, well, this is how an Arduino looks like. It's very small, it's compact. You've got a USB and you've got a power supply that you can use either. So you can also power it from the computer using this USB knob. This is the microcontroller which sits here. So in principle, depending on the kind of Arduino model you have, so you can actually remove this after you have programmed it. You can remove it and put it on the breadboard. Okay, and there are other things around here. We'll not get the details of that, but the most important bit are these two rows of slots here, right? So these are numbered, as you can see, and these are the pins which allow you to communicate with your microcontroller, and this is how the microcontroller interfaces with the external environment. Okay, and now if you look at it, there are several pins here. And amongst those pins, you have the voltage pins because you have to supply power to it. And also you can get power out of it, which means that you've got a 3.3 volt DC supply, and you also have a 5 volt DC supply on one of these rails. So which means that you can take a wire from here and plug it to a sensor or any other device you want to power. So you can power devices from this. It has analog input pins here, and it has got digital input and output pins here. So you can generate both analog inputs and outputs using this device. All right. Now, the idea is you can connect hardware devices to this and do a lot of things. And in one way, this is called physical computing. because if you have done programming in the past, so you would be writing code and based on the logic flow, you'll get some results. This is this allows physical computing in the sense that you're getting variables from the environment using sensors or any other material. So say even if you're measuring voltages, you can input voltages here, you can do some calculations on that, and then you can get some interesting results. So there are a host of sensors available out there which you can connect to this device. For instance, you can connect temperature sensors, you can connect pressure sensors, vibration, accelerometers, gyroscopes. You can connect all of this to this device and make some interesting applications. Okay, so what I can do is I can add a list of interesting applications to the Moodle website, and there you can check how people actually work with this Arduino. Right now, it is more important for us to understand how to get it working. Okay, so for that, what you need to do is, let me share my screen now. Right. So this is currently my desk. So this is my hand. Hello. So this is my desk, and I have actually prepared the Arduino in a way that it is already connected to some basic electronic circuits, and I can show you how this is going to work. Okay. So let's see if I can. I'll later share the full screen, so it's not going to be a problem. For now, yeah, that's better. So that's the Arduino, and here are some very basic circuits. All right. So to control this, what you need is something called an IDE, and this is an IDE. This is an integrated development environment, and this is how you actually communicate with your with your Arduino. So I got a USB cable which is running, and it is getting connected to my laptop, and I'm able to burn programs onto the microcontroller here. Now, if you also see carefully, let me see if I can see my own video. 1 second. Yeah. If you see here in this device, there is no microcontroller like the big one that you see in this one, right? So here you got a bigger microcontroller. Here you don't have that. Here it's called an assembly device, which means that you cannot remove the microcontroller. It's still there, but you cannot remove it. So depending on the kind of application, you want to choose which kind of Arduino you want to work with. Whether you want to work with something which you can remove the microcontroller from, or you're okay to use the Arduino with the microcontroller fixed on it. Okay. So now on this device, what I've done is I'm already running a program which is called Blink. And what Blink does is, let's have a quick look. Let me see if I can increase the font size. I don't know if I can increase the font size here. Oh yeah, I can. Relate. Okay. So I hope, so this is an IDE which you have to install from the Arduino website itself. Again, I'll put a document on Moodle, which gives you some of the links, some of the processes which I'll be discussing here. So you can directly go back to the reference material and you can yourself try these codes out. All right. So what you have to do is, this is actually written in the C++ language. This program is written in the C++ language. It's not necessary that you have to know programming to do this, because if you look at 3 or 4 programs, you start to get an idea of how you can write very simple codes. So any Arduino program has got 2 parts, one which is the void setup and the other one which is the void loop. So in the setup, you are initializing a few things. You are telling the Arduino that, okay, fine, I want this pin to be this as an input. I want to generate a PWM signal, whatever. So whatever you want to initialize it, you're doing it in the setup. Once the program finishes the setup part, it goes to the loop, and that loop part goes on continuously. It keeps on happening till you say the program to stop. Okay, or you just pull the plug. Okay, so it keeps on happening that way. Now here what I've done is, in the setup mode, I have said that I want the pin mode as LED built in. So here this is a command which says that there are several pins here, and I'm going to declare this particular pin which is called LED built in, or it is called number 13. So here, if you see, there are also a lot of pin numbers given here. If you can see my video, so here you can see a lot of pin numbers. Okay. So basically you tell the Arduino that, okay, I want to use pin number 13, which is also the LED. So pin number 13 connects with a built-in LED, and also you can connect an external LED to it. And you are basically telling it that I want to use it as an output. Okay. So you can call it as an input or an input. Now, once you initialize that, then in the loop you say that, okay, I want the LED pin to stay high for a certain amount of time, which is 1000 milliseconds. And then I want to bring it down to switch it off for another 1000 milliseconds. And this cycle will repeat on and on and on. So now if you see if you see the device here, right? So here, this is actually running that program. So it is running the Blink program, which is a very basic program, and it's like the equivalent of the hello world for C++ or any other programming language. It basically tells you how to get started. And this is what the Arduino is currently running. It is running a hello world program here and a Blink program. Okay. So it is keeping it on for 1000 milliseconds or 1 second, pulling it off for 1 millisecond, and it keeps on doing it till I do something, till I either remove the plug. So let me remove the plug here. Okay. So now I remove the plug. So now, because there's no power supply going into the Arduino, it stops. But here is the interesting thing. If I put the USB back in, see, it starts to blink again, right? And that's because the program is already burned onto the microcontroller. Even if you pull out the power supply, if you put back the power supply, the program is retained, and that's why it starts blinking. Okay. So unless you physically erase the program that's on the microcontroller, that previous program will keep on running. So you have to keep this in mind. And how can you erase a program? That's very simple. So what you can do is you can run a blank sketch. So programs in Arduino are called sketches. So here I'm running a blank sketch, which means that there's nothing in the setup, there is nothing in the loop. I'll just play run. Okay. Once I do that, that's it. See, it has stopped. Okay. It's still connected. It's still connected to my laptop. So you can see it here. You can see my finger. It's still connected. Okay. So we are not just going to use the Arduino for blinking LEDs. We want to work with it. We want to get external signals in, right? So one of the simplest ways of seeing how that happens is by connecting it to a potentiometer. So now a potentiometer, I can show you again. So you can look at my screen, at my video. 1 second, let me remove that. Okay. So this is a potentiometer, right? And a potentiometer is a variable resistance. Okay. So what you do is you connect an input voltage on one of the legs and ground the other, and you can use it as a voltage divider between these two pins, the middle and the ground pin, then it becomes a voltage divider. Now, when you turn the knob, the resistance changes, so the output also changes. The output voltage also changes from the voltage divider. What we are going to do is we are going to generate that voltage divider on the Arduino, where we are connecting one pin to 5 volts, the other pin to ground, and the middle pin to one of the analog inputs. Okay. And what we'll do is we'll use the Arduino to read the voltage drop across the middle pin and the ground. So that's what we are going to do. Okay. So let me do something. Let me shift my video now to, or should I be able to do that? Let's try. Let's just keep it this way for now. Okay. So I'll put it here. So I've already made the connections. So what I've done is I've taken 5 volts. So let me quickly. No, I don't think I can do that very easily. Okay, we'll just keep it this way. So what I've done is I have connected the voltage and ground to the outer pins, and from the inner pin. So you can see this wire here. That inner pin is actually going to one of the analog inputs. So the analog input A0. Okay, so it's going to the analog input A0. And now we can have a look at the program. So this is a very simple program again. It's called potential read. And in the potential read, what we are doing is we want to display the voltage that is being recorded by that is being seen by the Arduino at regular intervals. And to do that, we have to start a serial monitor, and this is how you start a serial monitor. This specifies at what speed you're doing it, at what data rate it's happening, and so this is you specify this, and then it's a very simple program. Let me do the following. What I'll do is I'll remove all the comments, okay, so that you get an idea of how small this program is. That's it. So this is the actual program. So first of all, you start the serial monitor. Then you say that you want to read the analog input that's coming into A0, and you're storing it into a variable called sensor value. See that it is actually storing it into an integer value. That is because what the Raspberry Pi does, or sorry, what the Arduino does. I'm teaching a Raspberry Pi course, that's why it's already. I'm always saying Raspberry Pi. So what happens is the Arduino actually, whatever voltage it gets, it scales it to a range of 0 to 1023, because it's a 10-bit ADC. It's a 10-bit analog to digital converter. Any analog signal that comes into the Arduino gets converted to 0 to 1023. Now you know that the voltage that you are providing to the Arduino or to the potentiometer is 5 volts. So any voltage that you observe at the resistor divider circuit is going to be in that range, 0 to 5. So the second line is actually for converting that sensor value that you get, right, into a scaled value. So you know that 5 volts will cut, 5 volts means full scale means 1023 values, and that's why you're scaling it. Then what you do is you print that value into the serial monitor, and you also put a delay of 50. Let's make it 500, okay? Because then only you'll be able to see it on the video. So now what we are going to do is we are going to first of all compile. Yeah, is there a question?
What is A note here?
A0 is the analog input pin. So where is it? So as you see here, so there are several pins on the Arduino. If you look at my video, there are several input pins on the Arduino. And if you see here, you've got the analog input, right? What I'm doing is I'm taking the output from the middle leg of the potentiometer and I'm connecting it to A0. So I have to tell Arduino that I am reading a value from A0 and it has to record it. And this is what this line is doing. So analog read is a function which knows that, okay, the analog value is going into A0. When you run the analog function analog read, it gets that value in the range from 0 to 1023 and stores it into the sensor. Is that clear?
Yes, sir. Thank you.
Okay, fine. So yes, now what you do is, because with any program, first step you do is you uh, compile the program. So once you're compiling the program, so here it tells you whether the compilation is successful or not. So in this case, the compilation is successful. Okay. One other thing that you need to check is if you have because this IDE supports different kinds of Arduinos. There are several kinds of Arduinos, and I'll be showing you one of them. I'll be showing you two of them actually. So what you need to know, what you need to make sure is you're using the right board. So you have to go to the board setting and you have to select the right Arduino. So I'm using an Arduino Uno. So I select the Arduino Uno. The second thing you have to do is you have to go to the COM port. The COM port is basically a connection with the Arduino. So you have to make sure that it's connected to the right one. So if you have connected an Arduino to the computer, it will show up as COM5 in this case and Arduino Uno. So you select that. So once you are sure that you have done that, only then press the upload button. Okay, because in some cases what happens is if you're not selected the right board, what might happen is it might burn something, it might erase something which is called the bootloader on the microcontroller, and you don't want that. So just remember, before you upload anything, make sure that you have identified your board correctly. That is number one. And number two, you have made the correct COM port connection. Okay, once you have done that, then you program it. Okay, so now that I have this, right, let me see I'll go to this serial monitor. Okay. When I go to the serial monitor, okay, so now it is printing a series of values. Okay, let me go back to the video. So now it is printing a series of values. What I'll do now is I will rotate the potentiometer and increase the resistance value. Now you can see that the resistance value is increasing, right? When the resistance value is increasing, you also have more drop. And now I'm at the middle point. Oh, yeah. Now I'm at the middle point. So it's reading 2.5 volts, slightly loose. I'll hold it down. Okay. Now I'm going to the maximum value. Okay. So I see that I'm getting a slight. So let me leave this to you as a question. Why do I not see the 5 volt? Why do I only see 4.9 and not the full 5 volts? Okay. So I leave that to you to think about. Okay. So this is the first program. You can also just simply output the raw value. So that's also possible. Okay. So you don't have, if you don't scale it, you can also get the raw values. Fine. So now, why is this program important, or why it is useful to know how to work with the potentiometer? Because in place of the potentiometer, you can have any other sensor. It doesn't necessarily have to be a potentiometer. It can be a temperature sensor. It can be a pressure sensor. You know that the Arduino is going to read voltage levels, read 1024 voltage levels, 2 to the power 10 bits, right? So when it is doing that, it means that any signal that you get, it's actually doing it in that range. So if you're doing a temperature measurement, you can scale it accordingly. Okay. So if you know how to work with the potentiometer, you actually know how to work with a host of sensors. Okay. You have to understand how the different sensors work. That is a different topic. But at least you know how to use it to communicate it, how you can communicate with it using an Arduino. So that's how you use it. Okay. Right. So now you know how to control a potentiometer. The second thing that you can do with the Arduino is, because you have an input, you can use that input to do something else. Okay, so that's what I'm going to show you next. What I'm going to do is I'm going to use the potentiometer, and I've got this LED, right? I'm going to change the brightness of the LED by moving the potentiometer. Okay, so let's have a look how that can be done. All right, so let me erase the current program, and I can do that by simply uploading a blank sketch to it. Right. So now when I upload a blank sketch to it, let's see what the serial monitor shows. The serial monitor has stopped. Okay, so the program is not running anymore. I close that. Okay, so now let me open the figure. One more thing, the programs that I'm using, it's all available. These are not programs that I have written. These are all programs which are available on Arduino, on the Arduino website, and example programs. There are a lot of very good example programs, so you can start from there. And I would recommend you start from the Arduino website and nowhere else. The reason is the Arduino website makes sure that all the programs that they give you run properly and they are compatible to the boards that they refer to. If you go to some other website like eGuru or whatnot, I don't know the names, but you might end up getting the wrong information, or worse, you might actually end up burning one of the pins. So first of all, get used to the programs that are already available on the Arduino website, and then move on to other things. So here, again, there are a lot of comments here. That's not a problem. Let's look at the structure. So here I am measuring, if you look at this code, I am measuring the potentiometer value using the sensor value integer. And I'm also creating an output value. Okay, we'll come to that later. I'm also creating an analog out pin. So there is an analog in pin, which is the A0, which is reading the potentiometer. And I'm creating an analog out pin at 9. Okay, and that's why I removed and I connected. So the video was not there. Let me show you. So actually, I connected the LED to pin number 9. Okay, on the Arduino. So now what I'm going to do is I'm going to go to that one and we can quickly walk through the code. Again, I have initialized the serial monitor. I'm reading the analog read. I'm reading the potentiometer value here. Okay, I've got the sensor value. Now what I'm doing is I'm mapping the sensor value, which is in the range of 0 to 1023 to the range from 0 to 255. Now why am I doing that? So the Arduino can generate different kinds of signals. It can generate analog signals also, but one signal which is very useful is called a pulse width modulated signal. Pulse width modulated signal is like a square signal. It's a square wave. But what you can do is you can change the width of the time or the time period for which the cycle is on. Okay, and that's called the duty cycle. So if it is on and off for the same amount of time within a given period, then it's called a 50% duty cycle. But you can reduce the duty cycle all the way to like even zero, which means that it's completely off. Or you can just keep a very small value open. So it's just on for maybe like a fraction of a second and then it's off for most amount of time. So that is called a pulse width modulated signal. And the advantage of doing that is you can now control the brightness with which your LED shines. So imagine the case where your duty cycle is close to 100%. Okay, that means that the signal that is coming out of the Arduino is on for a very long amount of time and only off for maybe like a fraction of a second. This means that the LED will be on for a very long amount of time. Okay. If it is, on the other hand, it remains on for a very short amount of time, it will be on for such a small amount of time you won't be able to even see it. Okay. So it means that for all practical purposes, the LED is off. So now if you generate a pulse width modulated signal, you can actually control the brightness of the LED. Okay. And what we are doing in this output value line is we are mapping the potentiometer value, which we measured earlier, to the width, which ranges from 0 to 255. So the pulse width modulated steps is of the order of 2 to the power 8-bit signal. So that's why you're mapping it from 0 to 255. Now, once I do that, I just say analog write, analog output pin, output value. Okay. So this is just printing out the value. That's fine, but that's done. And then I'm just delaying it for a very small amount of time. Okay. So let's see how, if I now run this code, let's see what happens. Okay. So let me move. So right now the potentiometer is sitting at the maximum. Let me first compile the code. It's always good practice to first compile it. Okay. Okay, so the code has done compiling. I'll again check whether the COM ports are active. So board Arduino Uno and board COM5. Okay, so this is also fine. So now I will upload it. Okay, I've uploaded the sketch. It is uploading now. And right, so the LED is on. Right. So now let me turn the potentiometer and you can see how the LED dims. Wait. Happened. There we go. Okay. My potentiometer is a bit loose. So I hope you can see the LED. I'm turning it. Halfway mark crossed and switched off. Right. So now because I've chosen the value in such a way, you can actually see it slowly blinking. Okay. But then again, yeah, there you have it. Okay. So what I've done now is I have taken an analog input value and use that analog input value to influence something else. So that is the takeaway message from here. So you can use a sensor, okay? And when you have the value from that sensor, you can use that value to change something else. It can be a servo motor, it can be a sprinkler, it can be some other device, an actuator, for instance. You can use that value to control an actuator, and that is an important thing. So now I've done the LED thing. Similarly, I also have a button here. So now you can very well imagine that what's going to happen. So what I'm going to do is I'm going to press the button and I'm going to switch it on and off. Again, this is also another example where I'm not using an analog input, but I'm going to use a digital input. Okay, so it's like it's either on or it's either off. So that's what I'm going to do. Okay. So let's go to the code. So there's a lot of code here, and there is a concept here. We can get to that later. You'll find some material there, but that's not a problem. Fine. I've already compiled the code, so I'm just going to upload it. Okay, done uploading. And what I'm going to do is this code actually works in the following way. It doesn't work in the following way. Okay, why doesn't it work? Because I have used the wrong pin. There we go. Okay, so the LED is on. If I press the button, it goes off. If I press the button again, it goes on. Okay. Now there is a specific reason why I've chosen these particular programs, because in all your applications, you'll be using a sensor, you'll be using the value of a sensor to control something else, and you might need to switch on and off something. So that is the reason why I've chosen these three particular programs. All right. You can use this as building blocks to make whatever application. Now the most important thing. So what I've done is I've shown you some very simple examples, and I've shown resistor, a potentiometer. But if you look at all the applications that there are for Arduinos and Raspberry Pis, you'll see that there are a host of sensors that you can use. And these sensors are, they use different communication protocols and do all of those things. Now it is quite tempting for you to, because if you open any website, you'll see that, yeah, you can connect this gyro temperature and humidity sensor to one of the pins, and you can connect that accelerometer to that. There are different kinds of chips available. But it helps if you keep track of what's happening currently in the field. Okay. And what's happening currently in the field is, you saw the Arduino, which was this, right? So this was the Arduino I showed you. It's quite big. Okay. And yeah, so you got a lot of pins and all that. Here's something else. I don't want to, let me see if I can remove it. Okay, let me not remove it for now. This is a newer version of an Arduino. It's called Arduino Nano BLE Sense. All right. What I would like, or what I would strongly suggest, is work with this. Okay. The reason is, the Arduino programming environment is completely similar. Everything is the same. So you use the same kind of logic that you would use to work with the Arduinos. But the important and the most interesting thing about it is, this has got a Bluetooth sensor. This has got an accelerometer. This has got a gyroscope. This has got a temperature sensor. This has got a pressure sensor, right? This has even got a microphone inside. So if you work with this, you don't need anything else, right? So if you're devising an application which requires, say, you want to measure temperature and pressure simultaneously, you don't need to work with this device, right? Where you have to connect those sensors physically. You just buy this and you develop an application based on this, all right? So look into the Arduino Nano BLE 33 Sense, and let me show you a very quick example of how you can use it, all right? So right now I've already burnt the code onto this device. What I'll do is I'll just connect it to my computer for the power. Right? So now I've connected it here. Okay, now it is connected to the computer. What I will show you is, I have configured now for this device to work as an accelerometer. Right? So what I'll do is I'll first change the board. I don't need to do this, but anyway, I'll show you where you can do that. So I changed the board to the Arduino Nano 33 BLE, and then I'll change the port to the Nano 33 BLE. Now, why did I do that? I did that because I want to use the serial monitor. I will now go to tools. I will go to not the serial monitor, but the serial plotter. Okay, so just 1 second. Let's see. This is an accelerometer. It's working as an accelerometer. You've got three axes on an accelerometer: the x-axis, the y-axis, and the z-axis. All right. You see this green line? This green line is actually at a value of 1. The value of 1 means that particular axis is subject to an acceleration of g, which is 9.8 meters per second square. All right. So now, if I rotate my accelerometer, let me show it in this way. Now let me rotate my device. All right. See how the curves changed. Now a different axis is now subject to the gravitational pull. Okay. Let me again rotate it. See, so the three different axes are now subject to the other ones are orthogonal to that. That's why you don't see the action of the gravitational force, right? So I can use it this way. So now this already has this particular device. Oh yeah, we can also do this. Right? So you can also sense vibration. So everything is packed onto this sensor. I recommend if you are thinking of an application which requires multiple sensors, think about working with this one. Okay, so I'll add some details on Moodle on where to find some more information about it. Okay, so yeah, so that brings me to the end of the Arduino, right? I'll put up a cheat sheet which has some examples and also some of the flow charts on how to get your Raspberry Pi, your Arduino up and running. So you can have a look at that. And I also put some videos about this Arduino Nano BLE. Okay, so have a look at that. Right. Now let's move to the Raspberry Pi. So this is my Raspberry Pi. And the Raspberry Pi looks very similar. So if you put it side by side, it looks the same green, right? It looks very similar. But actually there is a huge difference because this Raspberry Pi is a computer, right? We have got a LAN port, you have got USB ports, you have got USB cables. This is an older version, it's a Raspberry Pi 3. That's why it has got only one HDMI port. My Raspberry Pi is 4, so it has got two HDMI ports and has got an 8 GB RAM. So this one is a 2 GB or a 4 GB, I'm not sure. So that one. And again here, if you see at the top, you've got these pins. Okay, so these again, so this is why the Raspberry Pi is interesting because these also allow you to interface with real world electronics. So this is again allows you to do physical computing. Okay, so now here there is a catch. So while the Arduino can work with both analog and digital signals, this takes in only digital inputs and outputs. Okay, so that is the catch here. So if you want to use a sensor, you have to either use a sensor which already gives you these digital outputs, or you have to use a sensor along with a physical analog to digital converter. So those devices are cheap, they're not very expensive, so you can still link it to Raspberry. Now the question is, why would you want to do it? Because when you have the Arduino, then why should you break your head to get an analog to digital converter, connect to this, and yada yada yada. So the point is, when you're using a Raspberry Pi, you can actually, let's get confused. You can actually do programming with Python. Okay. Now, when you're doing programming with Python, you can simply write some very simple programs. You can get the data in, but once you get the data in onto your Raspberry Pi, you can do all the processing that you want. So you can even run machine learning algorithms, for instance. I don't know how strong or how powerful these devices are to run machine learning applications, but the important thing is you can load a machine learning application onto the Raspberry Pi and you can do whatever you want with it. So you can do some more heavy duty computing. On the Arduino, you've got limited processing power. So you can do some very simple math at the most. Nowadays, the Arduino Nano that I showed you, that's capable of much more. It has got more processing power. The older ones, they don't have much processing power. But if your application requires a lot of processing, a lot of analysis, then the Raspberry Pi is the way to go. Okay. So what I'm going to show you now is, again, I'll show you the real the Hello World program, right? if the I won't be able to enter into a lot of details on the Raspberry Pi because it's more complicated. I'll be very honest with you, it's more complicated to work with than the Arduino. So if you're developing some hobby applications, the Arduino is surely the way to go. But if you want to do some really heavy duty applications, you want to do a lot of processing, it's worth to spend the time and effort to understand how a Raspberry Pi works and develop your applications around it. I also have another course which is called IC231, and you can enroll to that course. There are lectures on that course. There are also practical examples on that course. So you can look into that Moodle page and you can also get some information about the Raspberry Pi. So that's centering around the Raspberry Pi. All right. But nevertheless, what I'll show you is I'll show you a Blink program and you can compare it with the Blink program that was on the Arduino. And you will see why that is slightly more complex. Okay. So let me open the Blink program. I hope you are able to read the screen. So here, now we are doing Python coding. So earlier we are doing in Arduino, you are doing C++ coding. Now you're doing Python coding. It's just, so the kind of programs that you'll be running, you might not need to use the full power of C++ or Python. So you might not need to use classes, pointers and all that. So if you have a basic idea of what your algorithm should look like, you can translate codes between Arduino and Python. Just you have to make some minor syntax changes and it should work. Okay. So the one thing that you need to keep in mind or when you're working with Raspberry Pi is you need to include a library which controls the GPIO pins. So these pins are called general purpose input output because you can program them as either as an input or an output. So that's why they're called GPIO pins. And you have to write a few things which actually set up the both pins. Okay, so there are a few commands here which set this up. So again, you're declaring what channel you want to use. So you declare the channel number. And then you say that, okay, first I want this channel to be an output because I want to blink the LED. So that's why you have got this, you set it as an output. And then what you do is again, you have this loop. So here you don't have a never ending loop. You can create a never ending loop on Python. But here what I've done is I've just made it make to blink the device 5 times. Okay. So now what I'm going to do is I'm going to run this program and I'll show you the outputs. Right, so now you can see the board here. What I want you to look at is this LED. Okay, so now this is my Raspberry Pi, right? And this are all the electronics that I've converted. So this breadboard has all the electronics which are connected to this Raspberry, right? So now I'll blink this LED. Okay, I'll run this code. So lose contact, 1 second. And yeah, there you go. Right, so I blinked it 5 times for an interval of 0.5 seconds. So you see the 0.5 seconds here. So I have done it this way. So this is again a very simple application, but you can now see why I call the Blink program as the Hello World program. I call it the Hello World program because you can see how different programming environments handle the same programming task at a less complexity level. So it's a very simple program, but you're already seeing a lot of differences. So my advice is if you are picking up any microcontroller or any microcomputer, start with the Blink program, and then you can be sure that, okay, you understand what is the level of complexity. All right. So now this is again a very simple thing. Let me show you a slightly more complex setup that you can do. And this is what the students are currently doing in the lab. All right. So what they're doing is, so this is a distance sensor. I think you might have seen this in some of the websites, or you might have even worked with the sensor. So this is a distance measurement sensor, and it works on the principle of ultrasound. Okay, so it sends out a series of ultrasound pulses. So one end sends out a series of ultrasound pulses. It reflects off from an object, and then it comes back to the receiver, which is the other head. All right, comes back to the other head. Internally, you have got electronics, which measures how long the pulse has been traveling in air. Okay. Once you know that, because you know the time of flight, you can calculate what is the distance to the object. All right. So this is what an ultrasound distance is, how an ultrasound distance sensor works at a very basic level. What I'm going to do now is I'm going to trigger this ultrasound sensor and I'm going to measure the distance. And what I can also show is I can show you on the oscilloscope how the output looks like. Okay, I hope you can see the screen. It will become much clearer once I run the program. All right, so let me move to the ultrasound program. All right, and let me put an object in front of it. Okay, so now I put an object in front of the ultrasound sensor, I've blocked it. You will see on the oscilloscope, you will first see a trigger pulse, which tells the ultrasound sensor to start. And then you will see another signal, which actually tells you how far this object is from this ultrasound sensor. Okay, so now I'll run the program. Now this program is slightly long because what I'm doing also is, you see this oscilloscope, right? I've connected the oscilloscope to the Raspberry Pi. So what I'm going to do is I'm going to trigger the ultrasound sensor. It is going to measure a distance. That data will be recorded by the oscilloscope, and I'll use the Raspberry Pi to pull the data from the oscilloscope and show it on the screen. Okay, so once I start running it, you'll be able to see what's happening. Okay, so now let me start running this. So it has established connection with the oscilloscope. Okay, now the code is running. It has acquired data from the oscilloscope, and now I'd like you to see the screen, the Python screen. Okay. So what you see on the oscilloscope right here is also getting recorded on the Raspberry Pi. So what I've done is, so just try to understand what has happened here. I have worked with an external real world sensor, got some data out of it, observed it on the oscilloscope, and I've also pulled that data out and I have got it now on my computer screen, which means that now I've got all the data and now I can work with this data. All right. So that is where the processor, that is where the power of the Raspberry Pi lies. You can work with different devices. I have interfaced an oscilloscope to the Raspberry Pi. You can interface anything else you want. Okay. You need to understand how the device works and all that, but you can do that. All right. And here is another thing. So now what I'm going to do is I'm going to run this in a continuous mode. Okay. Observe what's going to happen to the green device, the green signal, right? This green signal, the width of this green signal is actually telling me how far this device is, this obstruction is in front of the, from the front of the sensor. Now look at the green signal, all right? You see that? So it's actually changing when I move it because that's what I expect to happen. What this means is I can actually use this Raspberry Pi to make real-time measurements. And what I mean by real-time measurements is I can constantly trigger this device to constantly measure distances, like always, all the time it is measuring distances, right? And then I'm constantly also recording using the Raspberry Pi and the oscilloscope, okay? To give you an example of how this is happening, let me show you here. So you are just seeing one pulse here, right? So it's actually happening. I'm actually firing it multiple times, and every time it's actually giving me information, and I can keep on doing this. Right, so it's actually recording. So right now I'm close to, well, I'm not very close. Yeah. So again, there are some limitations here. We have to kind of work out a few things, but the idea remains that you can continuously fire your external sensors. You can get data from it in a continuous fashion, and you can do a lot of things with it. Yep. Second, yep. You can do a lot of things with it. All right. So now where is the, what is the problem here? Now, one problem I've already told you. Let me go back to my camera. So I already mentioned one problem or one limitation with the Raspberry Pi. The limitation is that the Raspberry Pi can accept only digital inputs. So you have to work with, you can work with analog sensors, but you have to put a chip in between, which is called an analog to digital converter, and then you can communicate with the Raspberry Pi. The other problem with the Raspberry Pi is you cannot do real-time applications with it. So when you're using an Arduino, you remember when I showed you the accelerometer function. So I was actually acquiring data in real time, and every time that the data was getting sampled, There is a timestamp associated with it, and it is well quantified. Okay? I cannot do the same with the Raspberry Pi. Every time I inquire it, what will happen is because the Raspberry Pi is also a computer, and because the computer also has an operating system, some operations of the operating system takes precedence over the operations that you want to do it. Okay, so it might happen that you want to fire the ultrasound sensor. You are trying to send a signal to it, but it gets slightly delayed. So you think that it's happening every 0.5 seconds, but it might be happening at every 0.8 seconds or even 1 second. So you cannot assign a particular time to it. And there are workarounds for it. You can use some advanced functionalities. But here is the thing. So here is where the trade-off lies. If you want to work with real-time measurements, where you want to actually keep on measuring with a very precise, defined interval of time, which is very fast, say it's like of the order of milliseconds, then the Arduino is the way to go. If you want to work with applications where you are getting data not at regular intervals, but maybe like every 1 second or 2 seconds, the timing is not going to be a big problem if the error is of the order of, say, a few milliseconds. Then you can work with the Raspberry Pi because you can work with the Raspberry Pi because the Raspberry Pi offers you the advantage of doing a lot of analysis. Right? Then you also have the analog to digital part. You have to think about it. Right? So these are essentially the pros and cons of using an Arduino and a Raspberry Pi. All right. So I will stop here. So what we did today, what I tried to pass on, what information I tried to pass on to you today was how you can get your Raspberry Pi started, how you can interface it with some very simple hardware devices like potentiometers, LEDs, buttons, and by extension, you can also connect some analog sensors. You can also use the Arduino to connect with digital sensors, but my recommendation is if you're using sensors like accelerometers, temperature, humidity, pressure, or even sound, work with the Arduino Nano BLE33 because it has got a smaller footprint. It's smaller in size and already has everything in it. There are already libraries out there so that you can quickly start. You don't have to physically do any soldering or breadboarding or anything of that sort. So explore the Arduino Nano option, Nano BLE option, BLE33 option, and that's very good. I also showed you some basics about the Raspberry Pi, and I showed you what the Raspberry Pi can do. I didn't actually get into the details of how you can get things going because it's too complicated to even cover in a 2-hour session or a 3-hour session. That's why we have a separate course for it. But I gave you an idea of what you can do with it. Right? So hopefully this information helps you to realize your projects in a more effective and a more impactful way. I'm more than happy to answer any questions that you may have during the course of your project. You can also talk to your mentors and you can also talk to other people who are working. So Siddharth is also working on IoTs and board devices. He is very experienced with networking. I am more from the side of measurements. I like to work with sensors. So if you've got some specific questions about sensors or how to interface them or how to work with Arduino or how to work with the Raspberry Pi, I'm your guy. So feel free to write me an email. Email is the best way to reach me and refer to the Moodle website because what I'll do is in 1 or 2 days, I'm busy today and tomorrow. Hopefully by the end of this week, I'll be able to upload all the material that is relevant to what we did today. I'll upload all the codes. So once you get your hands on a Raspberry Pi or an Arduino, you can start doing these codes and checking out how to work with these. All right. So yeah, so if you have any further questions, I'm still around. Otherwise, thank you for coming and keep in touch. All the best.